Hello everyone, so this is a video on factor formulae and conics. It's a great question this, and it's difficult, it really is. So I wanted to show you a question which involved using the factor formulae. Now one really annoying thing is I've just actually done a video on this and then realised it hadn't actually copied any of my screen. It was recording my other monitor, so yeah, this is a bit of annoying. So if I go slightly quickly through this, it's just because of that. Okay, so yeah, I put this up in class. I had a terrible day yesterday, totally fluffed my explanation, so I wanted to do this properly on a video. Look out for something like this, it could come up. But I mean, the thing is for this question is if you look, they tell you the exact page on the formula book you need to be looking at for this question. And I don't think I've ever seen an exam do that before. So obviously it's trying to tell you you're going to use some formulas you don't normally use, which are these formulas here. And the question is crying out for this. Anyway, let's have a go at it. So, equation of chord. Well, firstly, let's find the gradient of the chord. And the gradient is going to be, okay, so it's going to be 2 sine alpha minus 2 sine beta. So let's just do that. 2 sine alpha minus sine beta over 3 cos alpha minus cos beta. Okay, and let's use these formulas straight away, seeing as they're telling you, please use the formula. So we can, let me pull this over here, we can actually just use these to make this a lot easier straight away. We can rewrite this as, and I tell you what, if you throughout this question let alpha plus beta over 2 equal p, it's just going to make things a lot easier. And alpha minus beta over 2 equal q, you're going to have to write less down, so that's what I'm going to do. So sine alpha minus sine beta, well that's 2 cos, and I'm using this one, 2 cos p cos q, sine q. And then if we do this one now, cos alpha minus cos beta, you've got minus 2 sine p and sine q. The sine q's cancel, and you're left with minus 2/3 cot p, yeah, which is lovely. Minus 2/3 cot p. Lovely. Okay, now what I'm going to do is y minus y1 is m times by x minus x1, and I'm going to plug in what I've got. Yeah. So I'm going to plug in a point. I think y1 here is 2 sine alpha, and x1 is 3 cos alpha, I think it was, wasn't it not? Let's have a quick look, just check. X1 is 3 cos alpha. And I suppose now it might be handy to remind ourselves that cot P is cot of alpha plus beta over 2. Yeah? Now, if you look at what we're trying to end up with, we're trying to end up with y over 2 sine of alpha plus beta over 2. Yeah? And that's why I'm going to times this all by that, because I need y to be multiplied by a half sine alpha plus beta over 2. So, you know, probably this is the way to go. Okay, this is going to give me y over 2 sine alpha plus beta over 2 minus 2 sine alpha sine, oh no, the 2's going to cancel, but then you're going to be left with sine alpha plus beta over 2. Here, now the 2's going to cancel with that 2 down there, so you're going to get minus 1/3. Now remember, cot p is cot alpha plus beta over 2, and if you times it by sine alpha plus beta over 2, you're left with cos alpha plus beta over 2. Have a little think about that, but that is true. Multiply by x minus 3 cos alpha. Okay, if you look as well, when we times that by the x, that's exactly what we wanted, because on this side we wanted y over 2 sine alpha plus beta over 2. And then we wanted an x over 3 cos alpha plus beta over 2. That's handy. And then if I move this across the equals, I'm going to have sine alpha plus beta over 2 plus, and then when you do minus 1/3 cos alpha plus beta over 2 times by this term, you're going to get cos alpha plus beta over 2. Now when I was fluffing my explanation here, doing it in class with all of you sniggering at me, I'm sure, good for you, it was Dylan, I think, who pointed out you just need the compound angle formulae to finish it off now, so well played, Dylan. Because we can use sine A sine B plus cos A cos B, is cos A minus B, and that's exactly what I'm going to do on these two expressions. So I'm going to end up with cos of alpha minus alpha plus beta over 2, and if you turn that alpha into 2 alpha over 2 and subtract, you end up with cos alpha minus beta over 2 as required. Yes, we've done it. Yeah, what a fiendish question. Now part B, write down the midpoint of the coordinates of PQ. Okay, the midpoint, easiest bit of the question. Let's actually write it at the midpoint. Midpoint is just going to be the sum of the x's and the sum of the y's divided by 2. So we're just going to do 3 cos alpha plus 3 cos beta divided by 2, and the same for y. So 3 cos alpha plus cos beta divided by 2, and 2 sine alpha plus sine beta divided by 2. I think that's right. Let's just quickly check. Yeah, 3 cos alpha plus 3 cos beta over 2, 2 sine alpha plus 2 sine beta over 2. Okay, so last part. We've got to prove that this midpoint always lies on this line. That's the locus, if you like, as the midpoint moves when the gradient stays constant, which is an interesting fact, and we could show it on GeoGebra, and I might show you in class what this question looks like, because it's quite a cool little question. Okay, so what we're going to do, well, we've got our y coordinate here, and before we start here, let's do the trick we had before. Let's move this formula sheet down here, because we're going to need it. Let's just move it across, and let's just point out that we can now simplify our x's and y's, because this means that instead of writing it like this, let's write the midpoint like this. Once again, let's use these formulas. So this is like 3 over 2 times by cos alpha plus cos beta, and if we let alpha plus beta over 2 equal p, once again, and alpha minus beta over 2 equal q, we'll get the answer much more cleanly. We really will. It'll be easier to see what's going on. So what have we got for 3 over 2 cos alpha plus beta? Well, we've got 2 times cos p cos q. And so once you times it by 3, the 2 is going to cancel with the over 2. You're going to have 3 cos p cos q. I believe. Let's just quickly check that. Cos p cos q. Yeah, that's looking good. And here, because you've got sine alpha plus beta over, well, basically got sine alpha plus sine beta, this is going to be the same as 2 sine p cos q. Happy with that, I hope. Okay, so what do we know? We know that our y coordinate equals 2 sine p cos q. Okay, not very useful at the moment. Let's remind ourselves what the gradient is, though, because we're going to write this in terms of gradient times by x, or some function of the gradient times by x. Now remember, the gradient is minus 2/3 cot p. Okay, right. Now we need to introduce x. How do you introduce x? Well, what I'm going to do is write down, well, y equals 2 sine p cos q, and I'm going to times it by x over x, yeah, because then I can introduce x. Now I'm not going to do anything to the top because I want an x still hanging around, but I will cancel that cos q with that cos q, and I will rewrite this therefore as 2/3 sine p over cos p is tan p times by x, because all of that is x, yeah? Remember, I rewrote x as that. Okay, now the answer's easy, because all I've got to do now is 3m over minus 2 is cot p, and so minus 2 over 3m is tan p, and therefore this is going to be the same as 2/3 times by minus 2 over 3m times by x, and so it's the same as minus 4 over 9m x, yeah, and hence your k is 4 over 9m, and it's done. Okay, it's time for me to go to work because I'm a bit late, so yeah, thanks for watching the video, and yeah, keep up the hob. Bye bye.